Welcome back. In this video I'm solving Leetcode problem 1497. Check if array pairs are divisible by k. Okay. Okay, so we need to check if we can divide in pairs such that the sum of each pair is divisible by k. Here we got one example where k is 5, and we can see that there are pairs 1 and 9, 2 and 8, 3 and 7, 4 and 6, and 5 and 10, and so on. Okay, how to start with this one? Let's check out the situation. So the best thing is to write some possibilities. So essentially what we are doing, we are searching if the remainders of, if we can form a pair in which two remainders of those numbers are equal to k. So let's say we have for 7, so k is equal 7. We'll have each number will be we have either remainder 0. So in that situation it's already divisible by 7. That's a special case. It will have remainder 1. That means it has to have a pair that has remainder 6. Or let's say 1 and 6, they form 7 together and they're divisible by 7 then as a pair. Then 2, 5, 3, oh, or I can do it. So come on, 3, 4, and then it's 4, 3, 5, 2, like the opposite thing. And let's see, for k is 8, we'll have again 0, we'll have 1, 7, 2, 6, 3, 5, 4, and from 4 we will require another 4. So again, special case. Let me also write it. I'll leave it like this for a special case. Then 5, 3, and yeah, that's okay. So essentially the only thing you need to be careful in this task is to figure out those edge cases. So for 0, when remainder is 0, then you need to have, you take from the same pile of numbers with that remainder. So for 0 you have to take from pile where numbers that have remainder 0 are, and for even numbers you have to have you also have a special case for k divided by 2. So for that number you have to take from that pile again. So okay, that's kind of the intuition. So let's go this up. I will use counter, and we can put here I modulo k for I in array. And what do we need to do? So for key in count, so we have two edge cases. Let's do it like this. So key 2 is equal to key k minus key, but if k is if key is 0, then this would be 8, but we in like example when k is 8, it would be still 8, so we need to take modulo of it. Okay, and let me think about it. So for 4 it will be 4, that's okay. Yeah, seems good. And let's do like this. If key 0, then this will be again 0, and if key is, let's say, 4, then I'll have both 4. So for if key is equal to key 2, this means it's those edge cases when it's for numbers that are already divisible. We need to check so we need to check if there is like an even number. So if key is equal to key 2, and len of this and count of key modulo 2 is not equal 0, so there is not an even number of elements, then I return false, or else if so count of key is not equal to count of key 2. Not else here, but else let's do it like this. Because that wasn't correct. So and in this case we also return. So if let's say we have k is 8 and we have 2, remainder 2, key is 2, then key number 2 is 6, and if there is not an equal number of elements in both of them, then we also return false. And if this is all true, this is not the case, we return true. Let's try it out. I'll do it like this. So if count key, okay. Yep. And it seems correct. And it works. Okay, space and time complexity. For the space complexity it is off, and for this part So space complexity of n, and let's do, oh, and time complexity. So we are doing like counter, that's all of n, and also this part is all of n, so again all of n. Okay, thank you for following in this one. That's all I have for today, and see you in the next one.